Hello everyone, you're welcome to NEPH. I'm your tutor, Mr. Opuki, and if you're new to this channel, you're highly welcome. Do well to subscribe to this channel because in this channel we are going to be looking at physics, alright? Likewise, we've also been looking at math. You can go through the channel, there are lots of outstanding videos out there for you, in math, and now we'll be working on physics. So if you're a beginner, if you're new to physics, it's fine and okay. You are right on time, okay? So come and join this series of videos. So today we'll be looking at a very important topic in physics, okay, which has to do with measurement. So we'll be looking at a series of questions on the topic measurement. So we're going to start with the first question here. I'm going to read out the question, then we'll pick out the answer and I'll do some explanation. So we have in this series, we are going to look at the 5 questions. So this is the first question. So let's look at the first question. It says, which of the following is the SI unit of length? Now in physics, measurement is very, very important. When I mean very, very important, all over the world, when it comes to scientific approach in terms of measurement, okay, there is a request standard which the world has come to agree upon what units of measurement, which we call SI units. That's the international system of what units of measurement. So we have basically we have 7 fundamental units, which we have as a length. Okay, we also have we can say length or distance. We also have mass. We also have time. We have a temperature. We have the amount of substance, and we also have electric current and luminous work intensity. So from this question, we can observe that these are units. They are called fundamental units. Now let's look at their fundamental what quantities. Now for the last one, which is ampere, usually is electric what current. Okay, when you measure electric current, the unit is usually in what ampere. Now for seconds, we have it as what time. Time is the fundamental what quantity. Now for kilogram, we have it as what mass. Now for meter, we have it as what distance or what length. So the best answer to this question is what? Our what? Meter. Yes, for question number 2, we have on the board, the question reads, which of the following is not, a very important, is not a fundamental what unit in the SI what system? Like I said earlier, we have 7 basic what fundamental quantities and units, which we have the 3 most important is length, mass, and time. Okay. Then we still have others. We have like temperature, we have amount of substance, we have electric current, and we have luminous intensity. Now for this question, let's try to check which one is not a fundamental unit. Now for mole, mole is for the amount of substance. Amount of what substance? That's what mole stands for. Then we have now for force. Force is force is unit for Newton, and force is what? Mass times what? Acceleration. Okay. For candela, candela is actually what? Our luminous intensity. And Kelvin is what? Temperature. So from this list, we can observe that what? Now, mole is actually a fundamental unit, which its fundamental quantity has to do with the amount of substance. Candela is luminous intensity. Kelvin is temperature. So our correct answer to this problem is Newton, because Newton actually is the unit for what force? The product of mass times acceleration. For your fundamental units, okay, they are not derived from the product or the division of any what quantity. Okay, they are basic what quantities. So our correct answer to this question is C. All right, for question number 3, we have the prefix, okay, milli corresponds to which factors? All these are factors. Now, in physics, most times we solve problems, in different factors. For instance, we have kilogram. Kilogram means we have kilo there, okay, which has to do with 10 raised to the power of 3. So, for instance, 10 raised to the power of 3 here is what? Kilo, represents kilo, which means what? A value of what? 1000. Okay. Now we have 10 raised to the power 6. This one is what? Mega. And it means we have this as 1 million. Okay. 1 million. Now for these ones are very minute values. Okay, for instance, 10 raised to the power 6 is what? Micro. So we have it at 0 points. We have 5 zeros there and 1. Okay. Now for this we refer to as what? Milli. It goes with what? 0.001. So for instance, in physics, you say 1 milliwatt meter. So when you say 1 millimeter, it means you are talking about 0.001 meter. Okay. So the correct answer to this question, okay, that corresponds to milli is what? Option what? A. That is the solution. Right here we are in question number 4 in this series. So the question says a vernier caliper is used to measure what? So we are looking at vernier caliper. Of course, in physics, we have different instruments of measurement. We have, for instance, instruments using measuring length. We have our meter rule. Okay, meter rule. We have the vernier caliper. And we have the what? Micrometer screw what? Gauge. Yeah, we still have different kinds of measuring instruments for solid, for like we have as different scales. We also have measuring instruments for liquid and so on and so forth. All right, but for this case, the question says a vernier caliper is used to measure what? Now, first of all, it is used to measure what? Small distances. Okay, it's used to measure lengths, and it has high accuracy in millimeters. Okay, so a vernier caliper is used to measure. We can't say it's electric current, no. Okay, not the volume of liquids. We're talking about distances. All right. Now, large distances, no. Vernier caliper measures what? Small distances, very precise and accurate. But one other function of the vernier caliper is that it measures the thickness of what? Objects, of thin objects. So this gives us the correct answer to this problem. So we have this as the correct answer to this problem. Right, for the last question on this series, the 5th question, we have which of the following instruments is most suitable to measure the internal diameter of a test tube? All right, so if we have a test tube, okay, if we have a test tube, say we have a tube like this, I want to measure what? The internal diameter. Now, the idea is this. The first thing is this test tube is such that you cannot use a meter rule to measure the internal diameters. The meter rule is not going to work. What about stopwatch? We know stopwatch is usually used to measure what time. Okay, so it's not going to also work. Now, the question is between vernier caliper and micrometer screw gauge. What about micrometer screw gauge? Micrometer screw gauge is most often used to measure the diameters of, we have wires, okay? We have small bulbs, okay? And we also have a piece of paper, okay? You can use your micrometer screw gauge to measure what? A piece of what? Paper. And even small balls and the diameter of wires. So your micrometer screw gauge can do all of this, but it cannot measure the internal what diameter of what a test tube. So this is out, right? So the correct answer to this problem is your vernier caliper, because it can measure what? Both the internal and what? External diameter of what a test tube. Alright, so that ends this series, this introduction to the measurements of physics. So if you are new to the channel, kindly subscribe to the channel and share this video to somebody who may be of help. I'll see you guys in the next series. Bye.